So I think this is a good opportunity to have a look and think about, as an outdoor educator, the way in which we need to understand the landscape around us. And so I'm sitting on this little outcrop here, and we have to think about what do we need to know and what do we need to understand as an outdoor educator about the country and the landscape in which we find ourselves with our kids, with our young people. So I suppose in terms of understanding landscape, the first thing is to recognise is that wherever we go on the earth, there are only three big factors that impact upon what happens in any one place. About what grows, even what animals are going to be around, is all really based upon three factors, and they're big factors. One of them is the weather. Now the weather gives us sun and heat and energy, and remembering that the sun is a source of all energy and therefore all life on earth, the sun's pretty vital. So we need sun and heat and energy, and that's our first element, and that's going to be variable depending on where we are in terms of longitude. What also varies is water. Again, that comes from the climate, but the amount of rainfall that we get is really critical, and that's going to vary obviously and going to impact on what grows there. But the third thing, and this is the most variable, is what the earth has to offer. And by that I mean the earth is always made up of rocks and soils, but essentially soils come from rock. So really the most critical thing that's going to determine what grows in a particular area in any one time is really the rock. As it's breaking down, of course, it's going to form soil. And you know, to some extent, when we look at this is soil here that's directly come from the breaking down of the rock around it. And you can see that it's red. In this case it's moist because it's Ballarat. But there's a lot of clay in that. There's bits of sand and silt that have been washed off this over time and started to form this soil. Now, as it happens that clay sort of soils like that are pretty poor in nutrients, because this is very old rock. Sandstone, as you can imagine, because it's sandy and there's lots of water that's running through it, then all of the nutrients kind of get leached away, get washed away and deposited further down the valley. So up here on the crest of the hill, you get left with pretty crappy, poor soil. And as a consequence, the vegetation that comes from that breakdown is also not very, it's pretty spindly kind of stuff. This poor little eucalypt here really struggling to survive because the soils are so impoverished. Whereas if we were to go right down the bottom of the creek, that's where we'd have obviously more water as well, but also richer soils where these chemicals over time have been leached down to the bottom of the hill, and so that's where we'd get our good soil. So really, everything that grows on the earth is a combination of the heat from the sun, the life-giving moisture from water, but also the water providing that capacity to break down the rock into soil and then release all of those elements as nutrients into the soil, which enable trees to grow. And for me, it's a bit like the old-fashioned naturalist, a bit sort of Charles Darwin-like, where we're looking at the landscape around us. We have our scientific knowledge, from the 21st century and the information that we've learnt as scientists, but basically we're using that and blending that with what we've got as a keen observer and a thinker about the landscape around us. So this particular bit of rock, when we look at this and we say, what's happening here? And we can see that there's these areas that are really red, and we can see some areas down here that are really yellow. We've got this little stripy bit of kind of harder white rock in the middle, and we try to sort of say and try to understand what sort of rock these things are. Now we know there's only three sorts of rock, which makes it all pretty easy. Sedimentary rock that's made up of sediments, things that have been washed down and compacted over time. We know there are igneous rocks like Warren Heap and Mount Buninyong, which are basically volcanic, things that have been blasted out from the surface of the earth or have been molten underneath the earth and then later exposed, like the granites out at Beckworth. So they're volcanic rocks. And then the third type is really a combination between volcanic and sedimentary, which is where the heat of the volcanic rock in contact with the existing country sedimentary rock causes a change, a metamorphosis. So that's called metamorphic rock. If you drive towards the Grampians, you go over Mount Ararat. That's a metamorphic rock, which is the border between the granitics closer to the Grampians and the sandstone back where the Ararat township is. It's the same when you go into Bendigo, when you go over Big Hill. You know, that's a metamorphic rim, because metamorphic rocks tend to be super hard. It's a bit like baking a brick in a kiln. And so the brick doesn't actually melt and become part of the lava. It actually just bakes really hard, and then it resists the erosion. And in today's landscape, it often stands up as a mountain range or a range of hills, and that's what Mount Ararat is, or Big Hill around Bendigo. One of the things as an outdoor educator that you can look at when you come to a rocky outcrop or a cliff where you're going climbing is to say, what sort of rock is it? And usually you do that by just looking really closely at how it makes it up and looking at its hardness and its texture. And you can see that this is rock that's just sort of breaking off. And we look really closely and say, now, are there any grains, or is there a layering in it? And yeah, you can see that it actually has layers. And when we can split off little layers of this. Okay, so that's there's a good example. So there's a really pretty massive hint that this has been compacted into layers. So we know that it's a sedimentary rock, very fine, compacted into layers, and I'd call this a siltstone, because when I look at the granular size, it is tiny, like it's really small. So that would be a siltstone that we've got there. The other thing that tells me this is sedimentary is that it really has a definite, so it has these definite layers, but it's also been pushed onto its side over time. And that's one of the really important things to get your head around in terms of understanding rocks, is that these things have been around a long time. So rocks don't move quickly, except maybe in a volcano, but when we're talking about millions and millions of years, they can move a long way. So in this case, the rock that was originally layered flat has been tilted to one side, so we have rocks dipping. We have them dipping, and so you can sort of see, particularly down here, or this little bit behind me, you can see these layers. These layers are running along this way, and then they're dipping down here. And so this is the dip of the rock, and this is like, what is it, maybe 60 degrees, that dip. We also have a thing called the strike, or what direction the layers are running in. Now, as it happens, most of the layers of sedimentary rock, of course we don't have layers in volcanic or metamorphic rock, but in sedimentary rock, most of these layers, the strike of them in Victoria is running pretty well north-south. So if I'm standing here and I'm looking that way, that must be north. And it's a really good navigation aid. Like, I use it a fair bit when I was orienteering around the Bendigo area, because there's a lot of these exposed outcrops, and basically you'll know if you're running along here, you'll be running along a north-south line. And it tends to therefore be, if you think about landscape coming from geology, that the creek lines will often run in the same sort of direction. So your major creek lines will often be north-south creek lines, just because that's the lay of the land that's underneath. Okay, so we know it's sandstone, we know it's been tipped, we know the dip is about 60 degrees and the strike is north-south, but we can also see a few other things here. This really red rock up on the top also exists down the bottom, but then there's this yellow rock in the middle. Sort of what's happening here. If you think about material that's been laid down over time, that rock is made up of whatever was washed into that gully in the first instance. And that varies depending on where it's come from. And so you get different layers of rock that are coming in at different times, and they'll contain different amounts of chemicals. The red stuff we know is high in iron, in sort of ferric oxide soils. So it tends to, when it's exposed to the atmosphere, turn red. And then the yellower soils have a lower content of, or the yellower rocks have a lower content of iron in them. And so around Ballarat, there's a lot of this oxide type rock. The other thing to look at here is, again, just making observations. See what's happening in here. We've got this line of completely different rock. It exists there, and it exists here, and if I can just flick a bit of it out, maybe, it's really hard. Now this is sort of covered in moss and lichen, but we can kind of see that it's much whiter, and we know it's harder than this because it'll scratch it. So this is actually quartz. Now quartz, we know that this rock is younger than this one. It's really hard. It actually flowed in as a liquid. So after this rock was laid down and there were cracks that formed in it over time, this was underground and molten material flowed in along this crack. And you can see this really definite layer of where it's flowed in to this little minor crack here as a molten material, and then it's become solid. And in this area, of course, it's this material that carried with it the gold. And so this is what the miners were looking for were these veins of quartz that might have carried with them some gold. Particularly actually in this sort of country where it's sitting up vertically. So they know that because this crack, this vein of quartz, if you like, might go down metres and metres into the ground. And so the miners would follow that seam down looking for gold that might have come in with it. I mean, there's just so much interesting stuff.